Good morning again. This is Advanced Scientific Computing Training from Arctic. So Arctic is Advanced Research Computing Technology and Innovation Core that we formed recently. And with that, let us introduce ourselves. So my name is Suranga Edrisinghe. I'm the Associate Director for the Arctic. I have a wonderful team with me, and I'm really proud of my team. They are the best. So I'm going to go with this order. So Sanju, why don't you introduce yourself?
Hello everyone, nice to meet you all. I'm Sanju Timsina and I'm the HPC facilitator.
Great.
So that's it. Thank you.
Chris, go ahead.
Hey guys, I'm Chris Childress. I'm the application developer. I'm responsible for Elpis, which you guys have probably interfaced with, and I'm actually actively adding you guys to the project right now so we can actually have a hands-on demo.
Great. Scott?
Good morning, everyone. I'm Scott Burns. I'm the system admin, and I'm in charge for compute and storage for the Arctic team. And if you need anything related to those things, please feel free to reach out to me.
Great. So John is not with us today, but he's our DevOps engineer. He basically automates everything that we do in the backend, and he glues everything to function in a really nice fashion. I think we can deep dive into the specific tool. I think Chris will take over from here, right, Chris?
2 seconds.
Right. So I'm going to stop sharing and you can start sharing yourself.
Okay, can everyone see?
Yes, I can see you.
Can you see
Yes,
the
we can, yeah.
slideshow?
Right.
All right, so as you guys know, I'm Chris Childress. I'm in charge of Elpis at the moment, and I'm actually working on active development with this tool. What this specific website will do is it manages all of your projects and allocations in the cluster and allows you to, one, request resources and keep track of like all of the research that you have going on. So if you guys just want to play with this right now, you can do this as I'm talking through it. It's everything's located at elpis.rs.gsu.edu. You should be able to log in using your GSU credentials, and you should already have an account with an active project in the system. So none of you will actually have to request PI status to work on the cluster at the moment. And then once you do and have your own projects in the system, once we approve it, it'll basically create an allocation and automatically create all the resources that you have available in the system. So that's just kind of an overview of how it happens. So once you're a PI in the system and have a project, what you can do is you can automatically add users to your project, and that will actually give them resources under your account in Slurm. So Slurm is our resource manager, which basically performs all the calculations on the cluster itself and keeps track of who's doing what and what resources you're using. So when you're doing this and you add a user to the project, basically it gives them permission to operate under your account. And you can actually set up the specific role. The manager gives them ownership of your directories and iRods. A user will give them read-write access, and then a visitor will only give them read access. So when you add them to the system, it'll actually control what they have permission to do in your project directories. So when you're filing this PI request, it has basically project details, and once it's approved and you're a GSU user, you will be automatically granted a startup allocation. What that does is that gives you about 10,000 CPU service hours to do any type of basic calculations that you want and keep track of just performance and what's going on. So it'll also give you about 200 gigabytes of project storage, 50 gigabytes of user storage, and the ability to run 150 concurrent jobs on the cluster. When you're using those resources, if you get close to running out or anything else, there's a button in under your project that has request resource allocation. Basically, it's a form, you fill it out, you tell us what you need and why, and it will basically send that request to us. That will be forwarded to our resource allocation committee, and they will decide what you get and what's going on. And then once that's approved, you will be given, again, resources on the cluster automatically. So with this, once you're given a request or research allocation, basically what goes through is that you're given about 200 gigabytes of storage for the project, and then you can request up to 2 terabytes. After this amount, unfortunately, storage is expensive, so we can't support more than 2 terabytes per user. We'll have to actually charge you for additional storage. These allocations are approved for a 12-month period. After that, you can file for renewal or go through and request another allocation, or we can basically look at what you're using and what's going on. So with this, do any of you have issues accessing LPIS at the moment? So we're looking at signing keys. So actually, I can walk through this entire process. So everyone has some sort of SSH client on their machine. For Windows users, it's going to be PowerShell. For Mac users, I believe it's Terminal, and Linux users, it's also Terminal, I believe. But basically, to go through, you want to generate a key pair. Now, to do that, it's just SSH keygen, right? And if you've already have a key pair and can access the cluster, you don't need to repeat these steps. But for those of you that haven't had access, this is a good way to do it. So it'll generate a public and private key pair, and then it'll ask you to enter the file in which to save the key. I don't want to overwrite this ID RSA key, so I want it in my home directory, which is the tilde, then .ssh, which is basically where I store all my certificates, and this will be LPIS demo. It'll ask for a passphrase. Now, it's best practices to use a passphrase for your key. So it'll require a password anytime that your key is used. You can set it up to be whatever you want. For this demo, again, I will probably just leave it blank. It'll ask for it again. All right, and then once that key is made, you should see this following fingerprint. It'll be different for everyone. And then you'll have a key here at this location. So to sign the key, we want to get a copy of the public key that's available. So for me, that's going to be right here. You can open it with any text editor. I use Notepad++. It just makes life convenient. And then you'll just go right-click the pub. You do not want to open the private key. Right-click the pub, open with, choose another app, and then you should have Notepad available if you're on a Windows machine, or basically just want to open it up with any text editor that's available. So then you'll have this long string of stuff. You want to copy that to your clipboard, and then go to the Sign SSH Certificate link. Paste it available in here, click Sign Key, and then you will have the sign key available. Click Download Certificate, and it'll automatically name it and put it in your Downloads folder. For me, I want to rename it here. So I want to move this file to the .ssh folder. Delete this one. And rename it here. So this is my signed public certificate that's available, right? Okay, so then you'll have SSH-I for your private key, -I again for your signed public key that you just got. This will be in your downloads folder initially. You can move it to the same place as your keys just to make life convenient. Then it'll be arc login 01. I'm sorry, it's your username at arclogin01.rs.gsu.edu. Enter. And there you are. I believe you have to be on the VPN to access the cluster.
Yes, you need to be VPN right now.
So
Please try it out and let us know if it does not work.
and I think that pretty much covers everything that I was supposed to. For people that are having issues, we can do a breakout session and figure out exactly what's going on in your system, if you would like.
So I think then we will move into the storage piece. Scott, take it over.
Alrighty. Good morning again, everyone. What I'm going to briefly show you is how you can access or how you can bring your data into the cluster using Globus. And it's a pretty simple and straightforward process. And what it's going to allow you to do again is, and I'm moving a little bit ahead, but after me, Sanju will explain what iRods is and what you'll need that for. But essentially, you can use Globus to bring your files into the cluster and into iRods. So what you're going to do is use the Globus data management tool to bring in your data into the cluster, which will then allow you to move it, of course, within the cluster and to another tool, which is iRods. And in doing that, you will need to download an exe file called Globus Connect Personal, and that is the mechanism used to actually transfer the data uh, from your computer to the cluster and then into iRods as well. So it's pretty straightforward. Again, what I'm going to do is share how to do that with, and by bringing up the website here. Just a second here. And I'm going to move over to the website. Okay, and this is Globus. And I can drop that link into the chat for everyone. So, but essentially what you'll do is hit login here. And you should see this screen, and you would select the Georgia State University organization. And you would select that and press continue. And what this will do is, what it should do, what I'm going to do is back out of this, and I'm going to do it because it has cached my session. So I'm going to bring up an incognito screen so you can see that. Okay, I'm going to log in again.
Yeah, probably you need to sign out and then do it again.
Oh,
Yeah, that's fine. Let's try.
okay. And this should take you to the IDP screen for authentication, and you're pressing login. It should send you a duo message. Let's see. And accepting that. And this takes you into the system here. So what you would do from here is you would select File Manager on your left. And this will show you the collection area, essentially where you can place your data. And we have a few directories that you can do that in. So the easiest thing would be to type Arctic iRods, for example. And that's going to bring up a few directories that we have available for you to store data. And we have Arctic iRods work, and we have projects. Okay, so what I'm going to do, just for instance, some of your work that you would like here, I've selected Arctic iRods work, and it shows the current directories that you have available to you. And if you'd like to upload some data to this directory, you would just select upload and press continue. And let's see, I would select a file and I have just demo file here, and it uploads. And what I'll also show you is the .exe file that you need to actually upload those things, which is the Globus Connect. So I'll show you that here. And that is here, the install Globus Connect Personal. You would select this and it would download the Personal Connect client to your machine. And that's what it looked like. And you would follow the prompts there to install it if you're on Windows. And if you're on Mac, you would just select Show Me Other Supporting Operating Systems. So once you've done that, you should be able to go back to your file manager. And again, you can transfer or sync data between your computer and Globus, or you can also do it as you stated. Once we have things in place, you can move things within the cluster or from one cluster to another. And that's essentially all Globus is just a way for you to bring your data into the cluster. And relatively simple to do. Anyone have any questions for me?
So to add why we are using Globus, basically Globus provide high performance data transfer between endpoints. So when you install a Globus personal client to your computer become a Globus endpoint. So basically that client then act as an agent, and it modify your files when you ask it to transfer files. Basically chunk your file to small pieces and transfer those large file parallelly, like using multiple lanes. It transfer file from one point to the other point, and then the receiver end, it knows how to reassemble those small pieces to create your original large file. So using Globus, you can transfer large data with highly parallel fashion and with a lot of bandwidth. So that's why we are using Globus.
Okay, and also essentially that's it for Globus. Pretty straightforward. And again, as I stated, this will allow you to bring your data into iRods, which Sanju will explain what iRods is and how that works.
So basically, IRS is the data management software, and it virtualizes data resources. So here we are using the IRS for the data virtualization. So and where the data is, you can take control of the data using IRS. Currently, in our system, we have for the home folder we have 50 ZB quota, and for the project folders we have 200 ZB quota. So the home folder is /artic/home. You can see that your current folder when you log into IRS will be /artic/home and your username. And for the projects, it will be /artic/projects and your project name. Currently, you are using two resources for the home folder and for the project folder. For the home folder, we are using work resource, and for the project folder, we are using the project resource. So work resource has 50 ZB quota and project resource has 200 ZB quota. So if you want to put any files in the for the project, so please use the project resource to put the files. Let me show you. Start with the demo. So initially, to get into the IRS, we need to log into that. So let me show you. Run the init command. The PAN passport is the GSU passport. So use your GSE password. So you are now logged in, and you can see that your home folder is currently Arctic Home as Timsina. So now currently you are in the home folder. So in IDERS, instead of directories and files, we use collection and data objects. So basically collections means the directory or the collection of data objects, and data objects means the file. So everyone can log in and see if they can log into the IDERS. And please let me know if you have any problem logging to the IDERS.
Right, basically you need to log into the cluster using the method that Chris mentioned, generate a certificate, and then use the certificate. Once you log into the cluster, you can run this command that Sanjay is mentioning right now. The first command is init, and then it's going to ask you your campus ID password. So we just want to know that when you enter your campus ID password, it does not produce any errors. So please try it out and let us know if you find any errors.
Okay, then I'll start with the next slide. Please let me know if there is any issues. Also, we can put data objects or collection IDERS. Like I told you, we have work resource and project resource. Currently, we have the work resource as the default resource. So for the work resource, we do not need to specify the resource here. It automatically use that resource. But to put the file for the projects, we need to specify the project resource. Let's see. As currently I have these files. You can see in the ILS, in the IRETS file, I do not have any files currently. To put the file, I want to put hello.py into the IRETS. I can see the hello.py in the IRETS. So this is in the home folder. To move the folders, we can use ICD, just like in Linux, Windows, or Mac. We use CD instead of CD. We use ICD in the IRETS. To move to the project folders, we can see what are the projects using ILS/projects. So we can see we have this projects over here. Currently, this is our test project. We can go to the ICD and go to the projects. We can see the Arctic projects and the project name, which is UNIV1S16. So to put the files in the projects, we need to specify I put R hello.py. Okay, I put R projects. We need to specify the resource and the file name we want to put. And we can see we have hello.py in the Arctic projects universe. So this is the project folder and this is the home folder, the Arctic home. All the folders in the project folder can be shared by all the members of the project. So you can put those files in the project over here. Also, to put the collections, let me, okay, I have the folders called Soundfly, Slum file. So to put that, for the directory, I need to use the -R. I want to put that in the project resource, projects resource, and this file name. It is transferring data. That is lots of files, so it's taking time. We can use globus instead of IDERS to put the files so that it would be easier to transfer, since we can see that it's taking a little more time using the IDERS. We can see here the slum file in the IDERS in the project folder. Similarly, we can use those for the home folder also. So this is for the putting folder on IDERs also to get the file from the IDERs. ILS. Okay, wait. Let me, okay, skipping. LS, let me delete that. Let me delete hello.py from my current home folder. We have the hello.py and we can see hello.py and the so to get the hello.py, I can use iget and the file name hello.py. You can see here is the hello.py now. Also, currently we are in the projects directory. So to get any folders from the other directory, your home directory, you need to change the directory /rt/home and your username. You will only gain access to the files you are privileged to. So currently I only have hello.py on my home folder. So ls, let me delete the hello.py again from my no, ls there is no, and I can use iget hello.py to get the files. So this is it. Also, you can use the reference here. We have the IDERS documentation for the I commands. You can go look around on docs.iders.org master I commands, and you can see the commands the users you can use to look around the files. Okay. So to check the permissions, so we have permissions on every home folder and every project folders. Currently, to see the permissions, you can use ILSA. Currently on my Arctic home as Teamsina, I am the owner and the administrator is the owner. Let us go to the Arctic projects and the unique project name. ILS, we are in the Arctic projects and the project name. To see who has permissions on this folder, we can just do ILSA and we can see all of you over here. As Timsina Niranjan, the admin response. So you can see the permissions on your projects or in your home folder using the tab ILSA. Thank you. Do you have any questions around this? Okay, just let me do real quick. I haven't added the modules for the. Also, you can load the software using the module command. So module list, I have currently the loaded R modules. So to find the Python modules, you can do module avail Python and it will list the available Python modules. Here we have Python 3.7, Python 3.8.4, Python 3.4. And to load the modules, you can just do module load Python 3.7. So we can see
It's Python 3. Which Python 3, not Python?
Okay, yeah. Which Python 3
That's interesting.
Yeah. Okay, just let me try to
Okay. Yeah.
module load with the version. So module list, we can see the Python 3.8.2 loaded. We see which Python 3, we can see the Python 3.8.2 and being Python 3. So currently we have this list of modules. These are the dependencies that Python or R uses. So it loads all the dependencies to delete all the loaded modules. You can do module pause. And you can see that there are currently no module loaded. So that's it for the loading the softwares. Please let me know if you try to, yeah. Is there
I have
any
a quick
question? Yeah.
Yeah, I was just wondering, I looked at the module list, and I was wondering if when the modules from the old system, when all of them would be transferred over, or if that was the plan to, because there are some modules that I've used previously that I don't see on this list.
Right. So we are not planning to transfer all modules, but we encourage you to submit Hydra ticket for whatever modules that you like to use, and we will install it on our end. Because we have like a lot of, lot of unused modules, so we don't want to transfer everything. We like to know what is being used right now, and then we will make sure that it is available on the new system. Please submit a Hydra ticket.
Okay, thanks. And I guess kind of a follow-up to that, for how much longer will the old system still be operating, or possible to submit jobs in the old system?
Right. So that is something that we will need to take care really fast because the whole system is failing. So we would like to transition into the new system as soon as we can. So I encourage everyone to start using the new system and then do not rely on the old system because it's old. That's why we call it old system, and it's failing faster than we like to fail. So make sure that you transition into the new system and then let us know what you need to transition into. But we will try to keep the old system up and running until we know that everyone has successfully transferred to the new system. But it's not going to be a long wait. To view a little bit context why we use iRods, because I know it's an extra step, but the reason that we use iRod is iRod is a full-fledged data management platform. It provides us the ability to do certain things. So Sanju, if I can share my screen, I can show them.
Yeah, sure. I'll stop sharing.
Right.
Yeah, you
So
can share.
right. So basically, with iRods, we have this nice interface. Can you see my screen?
Yeah.
Right.
Yes.
So we have this nice interface. It's called aurora.rs.jsc.edu. You probably need to be on VPN to access this system. But what you can do with this system is you can manage your data by yourself. For example, here, now I have a couple of directories in my iRod system. So this is iRod workspace. So if I click one of these directories, for example, the first one that I find, so I can see the content, right? So then what I can do is I can select this and then click view info, right? So it provides us to create a metadata associated with the data itself. So one problem that we found is that when you have large amount of data, it becomes really hard to manage the data that you have. I mean, you probably come into situation that you even don't know what the data is because it has some arbitrary abstract names and you have multiple copies. So we would like you to have a habit creating a metadata associated with your data. Basically, metadata will tell you what this data set is all about, right? So then later you can search your data using the metadata. So it'll make your life a little bit easier, and then it'll help us to manage the data a little bit more efficiently, because the data is a really scarce resources. We don't have unlimited data. We have really limited data. The other thing is, once we allocate the storage to someone, we cannot allocate the same storage to someone else. So we really want to make sure that whatever we allocate to someone is being properly used by where we allocate the resource. The other cool thing about this interface is you can manage the permission to your data by your own. For example, I have this folder. Now I can add someone to my data as a user. For example, say, so if I want to share my data with Chris, I can add Chris as a read user and then set permission. And now Chris has read permission. So if I want to share this data with Sanju, so I can add Sanju, and then I can give Sanju write permission. So this is really easy way to manage your data and share data with the group members. So that's the main reason that we choose to use iRoutes. Any question on that? Okay, so every cluster uses a workload manager. The reason to have a workload manager is a cluster is a shared resources. We have many users using the system, and we have a lot of workloads being submitted to the cluster. So we need to make sure that we manage the system properly, and we provide equal access to everyone who is using the cluster. So that's why we are using a workload manager. So the way that cluster operates is, you're going to use your laptop or desktop to access the cluster as a client, and then you're going to log in to the login node of the cluster from your desktop or laptop using the method that we mentioned previously. So you're going to generate a SSH keys and then use those SSH keys to log into the login node. From the login node, now you can access the cluster. So basically, what users will do is they will log into the login node, and then they will create a job submission script, which tells the cluster what to do when you submit your job, and then submit that job to the workload manager, right? Then you can monitor the jobs that you submitted or interact with the jobs that you submitted. And then you can also query the workload manager and see how things is set up and what the partitions are, what queues you have, and things like that. So what workload manager do? Basically, it take care of everything that happening in the cluster, right? It accept workload from users, and then from that point onward, the workload manager is the thing that take care of everything happening in the cluster. So it matches your request to the available resources, and then it evaluates the priorities, and then it makes sure that everyone gets fair share of the cluster. And once the job start running, it tracks the progress, and it sees whether the job encounter any error. If there's an error, it try to report it back to you, or it can email you the steps of the job execution process. So it does a lot of things, right? It's a really important piece to have. And now, when you log into the cluster, you need to create a job submission script. That's the starting point. You need to have a job submission script to submit anything to the cluster. So it has key features. So job submission script should have a clear definition of consumable resources. And then it should have clear definition of execution environment that you are trying to use. And then you need to identify yourself and then tell that workload manager to use your credentials, right? So what are the consumable resources? Consumable resources are anything that you can use in the cluster, right? For example, you can use CPUs, you can use GPUs, you can use memory, you can use disk, you can use network, you can use software licenses. So anything that you can use is a consumable resources, and you need to define what you want to use and tell the workload manager that I need to use this and this much. And make sure if you do not request anything, workload manager is not going to allocate you anything. So it's only going to allocate you whatever you request from the workload manager. So for example, if you forgot to mention that you need like 10 gigabytes of memory, and then if you try to use more than 10 gigabytes of memory, it's going to terminate your job and then say that you don't have enough resources in the system. Even though the cluster node itself has like terabytes of memory, you're not going to get anything beyond what you request. And it's going to aggressively enforce those limits. So make sure that when you write your job submission script, you request everything that you need to successfully run your workload. And if you forget something, then good luck. And then workload manager going to rigorously enforce the limits.
Okay.
And then what is the executable execution environment? Basically, it consists of two things, right? You need to have an executable that you need to execute. For example, it can be a R script, it can be R or Python script, whatever. But then you need to have whatever the supporting software available in the system. So R script itself is not executable, right? R script tells R to execute the R command. So you need to have a R in your environment. So in order to load R, we use a module system. So basically, module is a way to create your environment clean and nice way, such that when you request R, it has all the dependencies associated with R, so that your job goes from point A to point B, like start to end, without any hiccups. So that's the reason of using the module system. Module system encapsulates all the dependencies into one single command, and it makes sure that you have all the dependencies. So suppose you have R script with you, and then you want to execute that. Now you need to load the correct R module to the system. So then you can use that R script as the command line argument for the R command, right? And then you're going to have input files and output file. You need to define what to do with the input output. If you don't define, workload manager does not know what to do, and then it can fail, or it can try to run. It's undefined, right? So then the credentials. So what are the credentials that you need? So when you log into the system itself going to assign you a username and group association for you. You don't have to worry about those things. So it's automatically you are going to get a username in the system, and then the groups that you are associate with your account, you're going to get those things automatically. But in Slurm, that's the workload manager, you have unique credentials. Those are called accounts in Slurm. So you get assigned to a different account when you create your project in LPIS. So you can log into LPIS and see what project that you have access to, right? So you need to get that information for you. And then there are different partitions in the systems that you can submit your jobs against. So you need to make sure that you you know where to submit job and what you can use. And there are also some sort of quality of services called QoS. So you can gain additional privileges by using QoSs, right? So these are the things that you will need to submit a successful job to the system. So any question up to this point?
All right, so clear this. Everyone should be in iRods and in the cluster, except for one user. Where was that? Except the one person who needed help with certificate generation, and we'll take care of that in a minute. So everyone should also have access to Slurm. So if everyone can navigate to Arctic, increase the font size here. Arctic projects, univ 1s16. And then ILS, they should see the job submit file and the test Python file. And if you don't, I believe there's probably a permissions issue somewhere.
I can only see the job submit file, not the Python file. Can you put that again?
You can't see the Python file?
No. I can see now, yeah.
Okay, so inheritance is working. It's good to know. So basically, you want to get the job submit script and put that in your local folder. Overwrite without forces, because I have it in my local folder. So I get job submit. And that'll put that in your folder, and then I get test python.sh. So you're going to put path error. It's because it's not a .sh file, it's a .py file. All right, so both of those are in my local folder. So let me go ahead and remove the output and error. So all I have in here is the job submit file and the test Python file. Everybody should be pretty much in the same place. So if we look at the job submit file, it is basically a bin file. It has permission to run on one node, one task, one CPU for that task, 600 megabytes of memory, which is a little excessive for what we're doing here, 5-minute run limit. It's associated with this account that everyone should have access to. If not, then we'll have different issues. We have the partition defined. It's the short CPU partition. The output of the script will go to the output file in our directory, and any errors that pop up will go to the error file. So to submit this, that's just the SBatch properties that we have. What it's going to do, it's going to change directory to the scratch folder. It's going to make a directory associated with the job ID, move into that directory. Then it's going to pull the test Python file from here. It's going to load the Python module, then run that file, put the results back in to your user directory in iRods, remove, and it should remove the directory as well. Take a look. Yes, and then once it's done, it'll remove the job ID directory from scratch space. It's good for everybody to clean up after yourselves, because it frees up the space for other users. If you ever run into memory issues, then we have to go in and clean up what's going on. All right. Then the test Python file is just a hello world. It'll write something to a file, and then it'll write something to the output. So to run it, it's just sbatch job submit .sh. Then it'll say submitted batch job number. Okay, so if it's asking for your iRODS password, it's just I in it. It'll ask for your campus ID password, and then you should be able to access it. And you should only have to do this once. If it ever gives you strange iRODS errors, it's always best to run init again because it stores your password and hashed in some file. So sbatch job submit, we submitted the batch job. So if we want to look at the jobs that we've done, it's saccount, right? It'll have all the jobs you've done under the account, how many CPUs it allocated, how long it took, the exit codes, and what's happening. But we should have in our directory is an output and an error. And hopefully the error is empty, which it is. The output is just hello world. I mean, we're programmers. I think this is mandatory. Then if you look in your home directory, which would be ILS, Arctic, home, your username should have this results file here. So if you want to grab that, and it helps if you type in the right path. And there's the contents. So that's basic walkthrough of running a job, what a job submit script should be. I can post that back up here. And how everything should be run. Does anybody have any questions?
I suggest everyone to try it out and see whether you run into any issues so that we can try to solve this as we close it.
But I think this pretty much covers use of the cluster and what we wanted to cover for the training, right? Then it's just support for people who are having issues.
Yes, and I think I forgot to show you the appointments that we made, Chris. Can you share your screen and then show that how they can book an appointment with us in the Arctic page?
So there's the ability to contact us. And then let's see here. So we have a booking site where we're working on figuring out basically what type of appointments we want to offer and what's going on that you can actually create an appointment with us. And I'm not 100% sure we have this live yet, but just basically come to the site, book an appointment, and we'll have more availability once we get this tool actually functioning. So
Yeah, that's the basic idea. So you'll have a place where you can contact us and then get help.
And if you book an appointment with us, you're guaranteed it'll be free time because it's actually synced to our calendar. So, was there anything else we needed to cover?
So I again posted the main entry point. It's architect.gsc.edu. So you can find all information you need there. So you can open the session for the Q&A and then general discussion from here on. And thank you very much for being here with us today.
Okay, thank you.
Thank you so much for the training. So I have a question here. So previously, I just upload the public key. I think in the early of March. So at that time, I can log in by PuTTY. So recently, I cannot. So I just re-upload a key. Now today, I can log in by the PowerShell. It's totally fine. But I still cannot log in by my PuTTY. So do you have any suggestions there?
Yeah, that's one limitation, I guess. Right, Chris? You can access the system using the PowerShell, and then it provides you a command line that you can use to submit jobs.
Okay.
And we are working on a web interface. I can demo you it on it's in a different system, but I can show you how it's going to look like.
Okay.
Let me share my screen, but this is not on the current system.
Okay.
But still, we will eventually deploy this to the new system. If I can get my screen to work. So hold on. So it's called HTTPS HPC 21. So this system, so you can if it works, I think it will work. So here you can access the cluster through a web interface. Basically, basically the cool thing about this is we have several interactive apps. For example, you can run Jupyter Notebook here, RStudio here, MATLAB here, Mathematica, SAS, Stata. So also you can have a interactive GUI. But for example, if you use this and then submit a job, what it will do is it will spin up an instance for you in the background. And then it will allow you to interact with that instance to a VNC connection. So you can say launch the desktop. So now you have access to the remote computer through a web browser. So this is basically a remote computer.
Okay, thank you so much. And yeah, please.
So also you can use a terminal from this web interface. So if it yes. So now you are in the system, right? So this is the alternative that we probably will provide you for this system. But we need to figure out how to we are still trying to figure out how to use keys with this system, because the current system we are only using keys, not the password. So we have to do a little bit of development on our end, try to make
so thank you so much. And I have another question related to how to run R here. So previously, when I try to run R, I have two questions. The first is when I install some new R packages, because I need them for my analysis. And after I install that, but when I try to run the program, it's it still doesn't work. This is the first. The second is my colleague, because he's not in US, he's in Canada, so he's a visiting account. He hold a visiting account, and his account cannot submit the, we just use a batch. He couldn't submit the R code. So I think we will try to figure out by ourselves first. We will try our best. If we still have questions, and maybe we will make appointment with you, I can share our screens and we will figure out what's going on there.
Yes, right. So in this system, one additional feature that we include is that in this system, we have a space called user app.
Okay.
If you install anything into that space, it's going to be available across the entire cluster.
Okay.
So if you install a package yourself, I suggest you to use that space, not your home folder, because home folder is going to have very limited space, only 5 gigabytes. But if you use /user app, then you can install anything there and you can set up anything there, and it's going to available throughout the entire cluster. But the caveat there is that it's going to be visible to any user because it's an app, right? But if you want to restrict, you can still restrict that, but we suggest you keep it open because it's an app, like it's not your personal data, it's an app. So it will be useful for other users as well. But if you want to limit the permissions, you can use ACL, it's access control list. So you can, using access control list, you can limit who's going to see this data, because you are going to own the app when you install it, and then you can change the permission of that particular place.
Okay, thank you so much. Anyway, we will try to solve it by ourselves first. If we still have questions, then we will contact you in the future. And we really appreciate for all your help.
You are welcome. Thank you.
Thank you.
Question? Any more questions? So did everyone able to log into the system at least? Any issues there? Because I don't see anyone, so I don't get any feedback. So that's fine. But if you run into any issues, we have Slack channel. You can join the Slack channel. You can post the questions there. We have the Hydra, that's the project management system. You can submit a help ticket there. You can email us. We have email arc. I'm going to post the email address as well. So it's called arc@gsu.edu. This is the email address. If you send email to this address, it's going to distribute to entire group. So some of us, at least one of us will reach out to you. So if we don't have any question, thank you so much for your time and enjoy the rest of the day.